All right, so let's continue with another application of probabilities in data mining, right? So which is called the market basket analysis. Right, so what is the market basket analysis? Actually, it is also called the association analysis, right? We are trying to find out how strong is the association between two sets of items, right? So this analysis most of the time is applied in different stores, different grocery stores or big market space. All right, okay, so there, for example, we have already talked about this example. So if you go to the Walmart, all right, so we have all different kinds of items, right? Thousands, even millions of items, small items, right? So where do we put them to increase the customer's experience? Right, for example, the computers and the earphones. You want to put these two kinds of items together, or you want to put them a little bit separate. You want to put the, let's say, the USB drive closer to the computers or the earphones, right? So all of these kinds of questions actually are based on the association of these two items, right? So we say if you go to buy a computer, do you tend to buy an earphone or a USB drive? Most time, kind of, yes, right? High probability, right? But the other way, if you go to buy a phone, earphone, then do you also go and buy a computer? The probability may not be that high, right? Okay, for example, the phone and the phone case, right? So then we say if you go and buy an iPhone, then do you also tend to buy a phone protector case? Most of the time, yes, most likely, right? So very likely. Then the other way, if you go and buy an iPhone protector case, do you also go and buy an iPhone? May not, right? So then we say this kind of association, we call this is the association rule, right? So this association rule, we always represent this rule with this format. We say the item set A implies item set B or not. This association is strong or not, right? So remember, this arrow here is one direction, it is not two directions. So just like if you go buy an iPhone protector, do you want to go and buy an iPhone? It's totally different with if you go and buy an iPhone, would you also go and buy a protector case? All right, so this arrow is only for one direction. It also called the implies. So that means the item set A implies the item set B or not. All right, okay, so then here, actually to calculate or to measure the strength of the association, right? Most of the time we use these two, right? We call the support and the confidence. Right, so now let's look at the support. So what is the support of this rule from A to B? All right, so then this support will be calculated with this formula. We say if you look at the records of a market, right, so then we say from all the transactions, within all the transactions you have, I want to know how many transactions contain both items. Okay, so if you didn't learn about probability before, you may just need to remember this formula. But once you understand the probabilities, what kind of probability is this? Is that just the probability of A and B, right? So actually out of all the possible outcomes, how many possible outcomes contain both A and B, right? So I care about these two events at the same time. All right, so then actually a support is just a joint probability. All right, so then next, what is a confidence? All right, confidence means what? So how much confidence that if you buy A, you will also go and buy B. All right, so then this confidence is actually a conditional probability. That means first, this person, right? So this customer should first already bought A, then how much chance, how large probability that this person will also go and buy B, so that in his basket he has both A and B. Right, so then actually if you look at this formula, is that just a probability that given this customer already got A, this A event already happened, right? Then what is the probability of getting a B? So that's both of these two item sets are involved in this basket. All right, okay, so now once you understand these two formulas, let's try easy examples. All right, so this graph kind of just the source why we call this is the market basket analysis, right? So whenever you go shopping, you always have the shopping basket, right? And then you have different items in your basket. All right, so then let's make a practice. All right, so if you have the rule of A implies D, so then how to calculate the support? We say the support has the formula of this one, right? Okay, so then in this case, we want the support of A implies D. So by the formula, A equals what? A equals to all out of all the transactions, how many of them contain both A and D, right? So how many transactions do we have totally? 5, right? Okay, then how many transactions contain both A and D? This one, and this one. Right, so is that just 2 out of 5? All right, so this is the support. Okay, next, what is the confidence for A implies D? That means the customer already bought A, and then how much chance he will also go and buy D, so that in his basket should have both A and D, right? Okay, so then how many transactions have A? So that means I don't care about the other one, right? So as long as it covers, as long as they have A, so this one, and this one, right? So we totally have 3 transactions contain A. Now within these 3 cases, how many customers also go and buy D? This one and this one, right? So that would be 2 out of 3. Got it? All right, so let's do one more practice. We say, what about, right, so what about this C implies A? Right, so now we want to get the support of C implies A. By the formula, it is a joint probability, so that means out of all the transactions, how many of them contain both A and C, right? Okay, so let me erase that. How many of them? 1, 2, A and C, so that would be just 2, right? Out of what? Out of total number of transactions, 5, right? So the other way for confidence, we want to calculate the confidence of C implies A. So then what does that mean? That means the customer should already bought C, and then how many of them will also go and buy A, so that both of these two items are in the basket, right? Okay, so then in this case, first we need to know how many baskets, how many transactions include C. That means this person, this customer already bought C, right? That will be totally out of 4. How many of them also go and buy A? This one, anything else? No, so that would be 2 out of 4, which is 0.5. Got it? All right, now the other case, we say in this example we are talking about 2 items, right? But remember our association U at the beginning, we say they are the 2 sets, right? The item set A implies item set B. So normally we don't talk about 2 items. We talk about the 2 kinds of items, 2 sets of items, right? So for example, this one, right? So it's not just the one item implies the other item. So now we have B and C as one set, D as the other set. All right, so that means, for example, let's talk about the support of this association, right? So I want to know the support of B and C implies D. Right, so then by the formula, A equals what? A equals to, out of all the transactions, how many of them contain both item sets? Right, so that means contain the first set, B and C, and also include D. Right, okay, so then how many of them? B, C, D, so that will be only one of them, right? So that will be 1 out of 5. Okay, now confidence of this association U by the formula. What does that mean? First, it is a conditional probability, right? So that means the customer need to buy the first item set. So that means the customers should already bought B and C. Okay, now the B and C are already in his basket. Now how many of them will also go and buy D, so that B and C already in the basket and also D is in his basket? All right, so then how many of them contain B and C? This one, and this one, right? So that means totally we have 3 transactions contain both B and C. And then within these 3 cases, which one also contain D? That means this customer also go and buy D. Which one? Will be only one of them, right? So that will be 1 out of 3. All right, okay, so then actually when you try to calculate the support and confidence, there is a very special case that we say, what if you have a very high value of confidence? That means if the customers already bought A, then they will also go and buy B. But what if these 2 items actually don't have any relationship or very weak relationship? It's just because the customers purchase B very frequently for not reason of B, right? So for example, when you go to the grocery stores for grocery purchase, then let's say, what if your A is a computer, and B is milk. All right. Okay, so then we say, if you go and buy a computer, then do you also tend to buy a milk because of their strong association? Probably not. But just because milk is a very popular item, almost a very large portion of customers go to grocery stores will always buy milk, for example. All right, so they go buy the milk is not because they go buy the computer and then they need the milk next step, but because the milk is very important for everyone. So that's why we have the high confidence here. All right, to avoid this special case, we create another value we call the lift ratio. All right, okay, so what is the lift ratio? It is a ratio, right? So it is a ratio of two kinds of confidence, right? So this confidence is still the same confidence we calculated before, right? So this confidence is still this confidence, right? We still care about if you go buy A, then how much chance you will also go and buy B. And then we say we create another confidence we call the benchmark confidence. What is the benchmark confidence? We say this benchmark confidence is the confidence when we assume these two events or these two item sets are totally independent. Okay, so now think about it. If these two item sets are totally independent, that means the item sets is independent of item set A is independent of item set B. A doesn't affect B, B doesn't affect A. All right, so then let's look at this formula again. If A doesn't affect B, B doesn't affect A, then if you care about B, what happened to the item set B, then what does this formula will be changed to? Think about it. If A doesn't affect B, then A is not important to B anymore, right? We don't need to care about B anymore. So that means the bottom of this formula will just change to all transactions because I don't care about A, right? If I don't care about A, then the whole bottom thing will be just about all the transactions, right? The same thing for the top, right? If you don't care about A, so that means A will be deleted. I don't need to care about A anymore. So then the top will be just about B, right? Okay, so then this is the idea of the benchmark confidence, right? So if we assume A and B are independent, that means A doesn't affect B, right? B doesn't affect A. All right, so that means this will become the benchmark confidence formula. So out of all the transactions, how many transactions contain B? I don't care they bought A or not. I just care about B. All right, so then what is this formula? Actually, is that just the probability of B? Is that just a marginal probability? Right? I don't care about A because A doesn't affect B, right? These two item sets are totally independent now, right? I assume these two item sets are independent. All right, so then we say if you get the ratio of these two kinds of confidence, actually we want to get a ratio of we say when we calculate this confidence, at the top, we are assuming that they have some association, right? So actually the top is the confidence of their association, right? And then the bottom is we assume they are independent. So then the bottom is the confidence of their independence. So if we get the ratio of these two confidence, and this ratio is larger than 1, what do you think? What do you think? If this ratio is larger than 1, that means what? That means the association confidence is larger than the independence confidence. So that means we tend to have an association. The association confidence is larger than the independence confidence, right? So that means we tend to have quite strong association. It can beat the confidence of independence, right? The other way, if this ratio is less than 1, that means the association is quite small, right? It is smaller than the independence confidence, right? So that means they tend to be more independent. All right, so then based on this lift ratio, we have the following rules. All right, so we say if a lift ratio is greater than 1, then it suggests that there is association between these two item sets. That means what? That means you want to put these two item sets closer so that we can improve the customer's experience, right? So the other way, if the lift ratio is less equals to 1, that means what? That means even though they are equal to 1, so that means association is the same with independence. So do we say they tend to be associated together? May not be, right? So kind of half chance, right? So then in this case, we say if the lift ratio is less equals to 1, then we say there is no, let's say not associated, no association. All right, so then I don't care where do you put it, all right, because there's no association between these two item sets. All right, so of course, the larger lift ratio, then the stronger association is, right? So of course, we want to see large lift ratios, because once we find a strong relationship, we always want to put them together to improve their customers' experience, right? Okay, so then again, let's come back to your essay assignment, the last question. All right, so question 3 and question 4 are both about our the market basket analysis. And then the difference is for questions 3, I just tell your information with different sentences. All right, and then question 4, I just summarize the information into a two-way table. All right, okay, so then for question 3, we say suppose a supermarket database has 100,000 points of sale transactions, right? So that would be what? That would be the total number of transactions, right? Okay, so now all of these transactions, within all of these transactions, 2,000 of them include both orange juice and OTC flu medication. All right, and then in these 2,000 transactions, 800 of them also include soup. All right, so now I want you to find the support and confidence for this association rule. So that means this is set A, this is the item set B. All right, so follow the formula, you should be fine. And for the question 4, right, so for the support I don't think there is any question about it, right? So SVG is short for saving account, CK is short for the checking account, right? So that means what? By the formula, we look for out of all the transactions, how many of them have CVG, the saving account, and also the checking account, right? So then how many customers have both accounts? All right, so try to use this two-way table to figure that out. So when you try to find the confidence and benchmark confidence, be careful. All right, so be careful about the formula, right? So especially for the benchmark confidence, we say out of all the transactions, how many of them include B, so which is the checking account, right? Okay, so how many checking accounts do you have? In this case, do you care about how many of them have the saving account or not saving accounts? Actually, I don't care, right? I just care about how many totally for the check, how many customers have the checking accounts in total. All right, so here be careful. And then I think we are totally done with the whole semester, and hope you can enjoy your Thanksgiving holiday. And at the same time, if you have some free time, be sure to start your review as soon as possible. All right, so again, our final exam is the Monday of our final week. So actually, you don't have a lot of time to prepare the review. All right, so start early, and the final exam is cumulative. Right, so you might just decide during the Thanksgiving holiday you want to review the previous chapters first, or you want to review the new material first. But here I want to remind you that in the final exam, 30% of the contents will be about the previous chapters because we have already tested them, right? So we don't need to put too much weight on the previous chapters, and we have 70% chance are about the time series and data mining part, right? About the new material. All right, so my idea is go through the previous chapters quite quickly, right? Going through their essay assignment and kind of bring back your memory about these chapters, all right? And then put more time on the new material. All right, okay, so the final preparation module is already there. It's already on Canvas. All right, so with the formula sheet, and I also create a study guide for the final exam because we have already covered so much contents, and then you do need to know whether you missed any important topics. All right, and of course you also have some extra exercise for the new materials, and if you want to review the previous chapters, you can always go to the exam 1 preparation module and also exam 2 preparation module, right? So I didn't cover these two modules in the final review module. All right, so just combine them together, and happy Thanksgiving. All right, see you next week.